Hey, I want to give you an overview of all the geometry nodes over here, but those are quite a lot, and I think I have to be very concise if I want to discuss them all in something like 20 minutes video. So let's start. A good suggestion is if you go to the Blender documentation, you see geometry nodes over here. If you scroll down, you see node types, and then you see attribute nodes, color nodes, curve primitives, geometry nodes, etc. And you go here to add, you see the same categories like attribute, color, curve primitive, and geometry nodes. So those will tell you exactly what each category is about. For example, you might wonder about the difference between geometry nodes and mesh nodes. If you take a look at that and you click on geometry nodes, you see that it says nodes that can operate on different geometry types. For example, volume mesh, but I know it can handle also curves. But on the other hand, the mesh node category, if you go over there, mesh nodes, it says that those nodes can only operate on meshes. So that means that this category has a bigger reach than this category. Then that's that. I show you quickly. I go quickly through this list of screenshots I made before. As I go over them, some are interesting, some are not so interesting. So we check that. So here I said the read info. Interesting here is that I'm using the capture attribute node. Because this is a mesh primitive cylinder, I'm going to transform it. You can find it in a geometry category. Set shades smooth. If I want to set this shade smooth or not. I click not, so it is not shade smooth. Now I'm going to capture some data of this cylinder. What I'm capturing is the normal. I use the faces. I want to know the normal of the faces, and that is vector information. I'm going to catch that information and I plug that in the output here, group output attribute. And then I'm going to use that later on in the shader editor. In the shader editor, I add the node called attribute, and there I type in DFG, so I can read that information back on the shader. I plug that in, and let me see if we see an example over here. No. Now, next one is scale on normals. This is very common. You will use this a lot. So you have here a mesh primitive, icosphere in this case. And you want to set position, you can find this in the geometry category, set position. In this case, I'm using the offset. And under vector, you find a node called scale. It's a bit hard to find, so I'm going to show you. So a vector and then a vector math. And here's a drop down, and here you see scale. So if I want to have for example, I have this cube here, I go to geometry and then I want to set the position. What this means is that I can control the position and the offset of each vertices separately, depending on the selection. I cannot do that with the if I go to geometry transform, you see these nodes, they have circle, and these nodes have a diamond shape. So that means that in this transform node, I cannot access the information I see over here in the position. I can do that with this set position node. So important is, if you work with nodes, some have the round socket. They cannot work with data like this list over here. If you see diamond sockets, that means you can have access to this all information and you can work with that. For example, I want to make, I go to input, I have an index. You see this cube has vertices and they are all indexed. Like, for example, this is vertex number 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh no, not 8. Until 0 to 7, that's 8 in our language. So, and then I can use that index as this one. I can use as to make a selection. And now only one is selected, I think. But I can go to the math node utilities, and there I see math. And there I can say a greater than or something. And then I can make a selection like that. So in this case, I selected some of the vertices, like listed here, half of them. And I use that as a selection, and then I do something over here. In this case, the offset on the Z. And only the vertices I selected got affected. And such a thing I cannot do with the transform node. The transform node, I can adjust the whole object or the whole mesh. So let me jump further. Scalar normals. Yeah, so there you find the scale I showed you. And in this case, we scale on the normal. That's how you do that. But often you want to use a texture to scale it. Very important here with this one. This is really important, the subtract. Because if you use this subtract by 0.5, then if you multiply, the average volume stays the same. So this point goes inward, that point goes outwards. If you don't do this, and you start to multiply, then the whole sphere got expanded or will get smaller. You try that out, that's really good. So icosphere, I'm going to set the position, and I use the offset. And what do I want to do with the offset? I'm scaling it on the normal. And how do I scale it? Well, I use a noise texture. I subtract this information with 0.5 first. And then I'm going to multiply. Multiply means that if I put the multiplication higher, then this point will go here, that point will go there, and this point in the middle will move inwards, so that's like more contrast. Here I have a grid set position node, and I do something with that set position. I use the Z, I move vertices in the Z location, but I make a selection and I use the index, those vertices that are numbered greater than 71, like that. So important here is, interesting is, yeah, in index and set position node. Modulo. Yeah, what is interesting to know about the modulo is that you can make repetitions in something. Let me see. We will see this later on. I have a better example. Scale texture. Yeah, I struggled with scaling the gradient texture, especially on spherical. But if you put a scale vector, node into the vector and plug that in the position, you can scale the gradient texture. I'm not going to show you an example because it takes too much time. and I want to keep the video a bit short. Capture attribute. Yeah, capture attribute is to capture some information and do something with it later. You can find that here, so add and an attribute. And then capture attribute. So in short, let's say I have a mesh. Let's get rid of this. I have a cube, mesh primitive, and a grid. And grid over here. Let's say I'm going to do a lot of things with the grid. But then later on, I think, yeah, I want to have those. Why can I see that? Wireframe. I want to have those two vertices, and I want to move them. I want to use it in the deformation edit, and let's say I subdivide it, I displace it with a texture. So then I can use this capture attribute, do something with the mesh, and then use that later. We can see that here. This is a very simple example, but here I use the capture attribute. What I'm going to capture in this case, that is just the index. So those are those vertices that have a number. And I make a particular selection. And then let's say you do a lot of things with that mesh, and then you use this selection later on. Next one. Here you see a good example of the modulo. So initially this is a grid. So imagine a grid like you see all the time in Blender if you place a grid. But here I make a selection based on the index, and then here I use a modulo. And that means something like, select every, it's like a repetition, like what you see here. I cannot explain it well, but I think maybe you can see it in Blender documentation. So modulo. But they use that a lot to get repetitions, like select every 3 or something like that. Let's jump to the next one, because I really want to keep it short. And here I delete geometry. You can also delete geometry. It's better than using a Boolean, because Boolean, that takes a lot of computations, it seems. If you can, better is to delete some geometry, and then you can do that with this node. So you can, I think, go to geometry, delete geometry, plug that in. Now it deletes everything. But I can make a selection, and if I go to the math node, utilities, math, and let's use this for well, you see that I'm able to I have to put it on face, of course. So you see what the modulo is doing. So it deselects or select every other in the count. I don't know how to explain it. In Euler, yeah, this is so in the rotation you have to plug in rotation information. So I think I use here curve tangent. I think I have to use that in the rotation information. But anyway, this seems to work also. And in the vector, you plug in information that is vector information. And this node says Euler to vector. So you see here, this is a cone, and the cone stands up by default. And I have a curved circle, Now I want to align the rotation of the cone to the curvature of the circle. So, and for such a thing, you use align Euler to vector. Here another example of align Euler to vector. I'm not sure if I use it correctly here, but in this particular case, it seems to work. So I do something similar. I have a mesh circle. Then what am I doing? I have also. I use that same circle. In this case, I have 6 sides. I use that also as an instance. And then I want to align those instances on the curvature of the of the original circle, and I use the position for that. A bit weird, but anyway, you got then something that lines up. Here another example. I have a circle. Resolution is 12. But I have also a cube. Well, how do you call that? Not a cube anymore. But I want to align that cube with the curvature of the circle. I think I didn't use it correctly, but in this particular case it works. So I think I should plug in the tangent and the rotation information. Not in the vector, but you know now what the align Euler to curvature is. Here this is not correct because I found out later when I move the size of the cube, its size a bit strange. Alright. So let's jump on next one. Over here. Curve parameter. The curve parameter it stores information of all the control points in the curve. So let's say I have here a resolution of 256 control points, I think. But this curve parameter outputs a value between 0 and 1. And those values represent the index of the control points. So if I plug that in over here and I say give me half of all those control points, so that's what you see here. I put it in the selection, and in the set position node I put up the set position, so half of the circle got those third control points got higher up in the set. This is really, really interesting. So I see here you have a curve line, and the length is about 5 meters. And I use resample curve to subdivide the curve, let's say. And this curve parameter outputs then, with this math node, I select half, not half of the, I select a few of those control points, not all of them. So the selection is here, this one. And what I do with that, I change the radius, because there's no set curve radius. So I'm changing the radius of that curve under this selection, and I'll do something interesting with that. So this is a cosine and sine, those gives waves. If you plug that into a selection, and this selection, that is the index is what you see here, or you've seen here before. So all those vertices are indexed with a number like that. And if you plug in such a data, if you plug that into a sine or cosine, then you get a waveform. And you can control the waveform with add and multiply on this place, and also add and multiply on that place. Usually you first multiply, I believe, and then add, like here. So multiply before the cosine, then you control the frequency, and if you plug that in, plug and multiply after the cosine, you control the amplitude. That's very interesting if you play with that. Let me see, do I have, yeah, there's another example. Then I have here an example. This has nothing to do with curves. There's a float curve, but nothing to do with curve primitives. So you see, I have an icosphere here, mesh primitive. I set position node, so that means I have control over all the vertices. And then I use the position. Important here is that I plug in position node. So that is like a field, and you can find it over here. So you go over here, input, and then here you see nodes that are actually fields. And if you want to change the position, often you want to get the current, this is the current position of the mesh. So I delete this one. I go to geometry, set position, go over here. And if I want to do something with this position, yeah, if I, for example, go to, I think, scale or something, of what did I do here? Oh yeah, now let's do this float curve or something. No, I'm not going to do that, but that takes too much time. So if I don't use this one, then all the position got collapsed to 0, because I need, as reference, I need the current position of the grid. And then do something with that position, like add or multiply. So that's what you see here. I'm going to multiply the current position with something else. So that's it. And then if I use this float curve, you can find that over here, float curve. Then I go to utilities, and then you see float curve over here. So that's very interesting if you want to make a mesh and you want to paint the mesh like that. So I'm going to separate the position that exists of x and y and z axis, information of all those vertices of this position, and then I can paint with that with the float curve, and to you can use a map range to how do you call that, adjust a bit. But this is most important, float curve. You see this shape is coming back over here. You can combine it back into, because now here I combine this curve and I use that for the x and y axis, x and y. Here another example. So I have the same curve, same setup, but now I use this only for the z information. So I see here a dip, and I see this dip, I see that now over here, but here is different. So let's say I see a bump over here, and I see this bump back over there, and that's on another axis because I use this axis over here. And this is another one. So I have here a curved line, and if you use a line, you have only two vertices, two control points, but you can resample the curve, so I have a count of 10. And then you can set curve radius. I think you can find that here. Add curve and then set curve radius somewhere here. So with that you can modify the radius of the curve when you use curve to mesh. And then as profile I use curve circle, but I control the radius with this one, with the float curve. And keep in mind that if you use the curve parameter, so that is the one that has stored all the control points, and it counts from 0 to 1. You plug that in the value, not in the factor. You have to plug this in the value. And then you can paint something like that. The curvature of this one, you can make that with this float curve over here. Another example, this is not that good example. This is also interesting. So here, let's see, we have a curved line, and we resample curve has only three curve to mesh, and that's that. That's strange. Well, anyway, so but then I have a profile, and it seems I'm going to do a lot with the profile, not with the curve itself. So what I'm doing with the profile is set the position. I'm doing an offset. I scale it on a normal. How I scale it on a normal, that is this way how I do it. I'm not sure what a fraction does, but if you use two float curves, this one is set on, let me see. Yeah, two float curves. All right, yeah, this is the overall shape, and then I refine it with that shape. Yeah, this combination gives this kind of effect. Curve parameter again. And that is the index of the control points, and I use here an integer. So I multiply that with an integer. I can adjust this to adjust the shape over here. Another example. So I have a UV sphere, and I set the position. What I use is I use an offset. I scale it. And then I use vector curves, but here you see I've selected X axis, Y, and Z. And I use the position as information, as reference. I use the position of each control points, of the each vertices. It's a bit hard to see what each curve does what. Curve radius, we've seen this before, very interesting. I love this kind of modeling. So you have a curved line as 5 meters. I resample the curve so it has 50 control points, and here I make a selection, and I use the endpoint end size selection of this curve. So I use this part and that part, and then I set the radius of that. To set the radius, I use the index, and that's all the vertices. Yeah, I can use it for measure also. But again, I use cosine, and that is to make a wave like that. And you can use multiply on this place to set the frequency. On that place you adjust the amplitude and add. That's a scale or the offset. Depends on what place you are using that. Index twist. So we have a line about 5 meters, it's pointing up, a line. I resampled the curve. It has 23 control points and instancing points in this case. And then I use the rotation. And I use the index, and then I multiply each index 1, 2, 3, 4, 5, etc. So I adjust then the rotation of the twist, how fast it is twisting a lot or a little bit, like that. Here you see an array, and in this case I use modulo. That's the most important part of this one. So so it's a cube. The cube is an instance, but there must be another instance. Oh yeah. So there's also a cone. So actually I have a line. I have two kinds of instances, a cube and a cone. And then I say I count the index of each line, and then with modulo I say each 4 and put a colon there, like that. So you see that here, modulo, and you see number 4 in there. Okay, you can animate. I animated this icosphere. I was able to animate it like that on the spiral. To do that, I used the trim curve node, and I use the endpoint selection. So those are the most important ones. I think trim curve is the one that makes you animate the cone, I believe, but I have to double check. Transfer attributes, I think I've discussed that, right? Raycast, also interesting. So let's see. Raycast, you see, important to realize is you see target geometry. There is no input geometry or output geometry. So in this case I have a grid, that's this thing, and a cube, that's that one. And the cube is affecting some displacement on this grid. So I have a grid over here, and I set the position a bit higher, but a selection I used a raycast. And this raycast has done the target geometry, that is the cube, because the cube is influencing the selection, and so also the offset in Z of the grid. So to keep in mind is then if you use a raycast, you use then as target the object that is the cause of the deformation, something like that. Proximity, where is the node? Proximity, also here, we have also a target. It's like the same story, approximately. So I'm not using geometry proximity on the grid as target. So the grid is not the target. The target is the UV sphere. So if I move the sphere around, then the grid got deformed there. Another example. Maybe it's a bit small, that example. That's very interesting. So I have also in the geometry proximity, use the distance output, and I plug that in the group output, so I can use this information in the material shader. Yeah, you can make patterns if you use sine 2 times, like that. So sine gives a wave. You can make like bars with that. But if you rotate one bar, so here we see the sine wave on the x-axis, but here also sine wave on the y-axis. So that's rotated, and then you can make a grid like that, and you can do all kinds of things. You can also make a circle. How do we make a circle in this case? Let me see. Oh, okay, we have a grid. We capture the attribute that is the position, and what we are using, that is the length. We use point and vector, and we plug that into the float curve to make refine the shape of this curve. So that's that little ridge over here, and that's this one. But if you mute this float curve, you still see a circle curve like that. And then you can adjust it a bit, set the position right off the... I'm confused myself now, right now. Okay, so I'm using the Y location. Oh no, the Z, sorry, the Z. The Z location of this grid. Alright, I think the video is getting long because I'm losing some concentration. Now, to make a triangle with only math, that's really difficult. The most important ingredient is to use a tangent. And you can look it up. There might be some information somewhere, but yeah, I show you a link. So if I go to trig, and there is a link somewhere. Here, Book of Shaders. So if you go to the Book of Shaders, then you go to Shapes, and then you go to Rectangle. You should see how it is done. So you can see all kinds of math. Switch. Yeah, switch is simply that you can make a switch for the user, or for example, here I plug the switch into the group input, and so that means that if you go to the modifier stack, you see here then the switch, you can switch it around, and then you can do all kinds of stuff. So if it's switched on, then this one will be used, this line. And if this is switched off, use false, then this line will be used. So that's interesting if you want to make switches. Yeah, you can also use a Vertex Group. I'm not going to cover that, but you can use that. But the thing is, you need original geometry, so I cannot use it on this grid. Because the original geometry is this. That's this cube. If I go to this cube and I go to Vertex Group, I go to edit mode, like that. I select the face. I cannot read my keyboard. Select this face, assign. Okay, I have a group over there. And then I can use that in geometry nodes, but not this grid. Not this grid. It doesn't have Vertex Group. Let me see. So we have a face. What information do we have? We have a normal. If I use that one, no face corner edge. Yeah, here we see a group over here. We don't see that on the grid. So that information is gone if we use the grid. But if we use our horizontal cube, we have that. And we can also use we can also use Vertex Group, Wave Paint, and Vertex Paint even. So that's really cool. Yeah, if you want to use that, there are some things to keep in mind. So we need to use an object outside of geometry node, otherwise it won't work. Or you can, what did I write? Or you can also make a mesh, assign vertex groups in edit mode, and connect the geometry and group input. All right. So the vertex group is a type of float. You have to keep that in mind. Waypaint also a type of float, and Vertex Paint is a color. Then Vertex Paint, you can use that, also very cool. You can even use drivers, but I don't see really the use of that, because if you use drivers you don't see a connection. But you can make drive a lot of things outside of geometry node into geometry nodes. Oh yeah, there's one thing I want to discuss more, and that's the order of operations. So often you see a formula on other websites and you think, I want to use that for geometry nodes. For example, here, so I go to geometry nodes. Math formulas. So I suggest you can use this website, but don't subscribe on anything, because I checked some reviews of this website and said, yeah, very nice website, but as soon as I subscribe, you got my phone number, my email, and now I got a lot of spam. So, but I recommend not to subscribe as long as there are bad reviews like that. But it is safe if you can see a lot of information, very useful information. You see a lot of formulas. Let's see if I can. I'm not sure if this is useful. All right, I have no idea what it is. But let's say you want to use this formula into Blender, and you see here are brackets. But in Blender, we don't have brackets like that. So how do you deal with the order of operations? So that's quite simple. We have to do it manually ourselves. For example, if we see 5 plus 2, that means we have to manually start with 5 plus 2 and then multiply. And we always count from left to right. You see, this node comes earlier than this node, because we are reading from left to right, even if we are using fields. They say a field starts to read backwards, but that's not the case for the order of operations. I checked that out, so I'll show you. So here, you see I have 3 times 5 plus 2, and that's 17, right? Because you multiply first 3 with 5 is 15, plus 2 is 17. So, but if I do that, you see here 21. If I'm using this connection over here, so I have 3, and here I have 5 and 2. But if I use this connection, so then I got 21. You see it here, 21. And if I change the other way around, I multiply first and then I add, then I got 17. So if you do it this way, you have first add, then you get 21. But if you first multiply and then add, so you have to read from left to right, and you have to look at the node itself. Not and you can forget all about these connections here. Check the node itself. First I do the multiply and then the add, and then I plug that in here. And here I do first the add and then the multiply, and then plug it in there. Another example. So here I'm using fields. So they say, if you use fields, no one's going to read backwards. But that's not the case for calculations like this. So this is still, you need to use from left to right. So here I do first multiply and then add. 2 times 3 plus 1 is 7. And this gives out 7. And so this cube is on the position of x is 7. And here, if I use this one, if I do a first add, 3 plus 1 is 4, 2 times 4 is 8. This position is on 2, sorry. So, and then you get 9, because this position isn't 2. You got 9. So that's very simple, just read from left to right, and then if you see brackets, you have to do that manually yourself. So if you see a formula on a website, you see here this one, I don't know. I don't have a good example, but if you see a formula with brackets, maybe like that, you have to do then first what's in the brackets, and you put that on the left side, and then you find out the order of operations. Another example there. And that's it. I think that's long enough for this video. Let me see if we see something over here. Did I forget something? Color, curves, and I discussed that enough. Raycast, alright. Yeah, here you find, usually those are fields like that. Instances. Yeah, I think I discussed enough. Alright, yeah, so I hope you enjoyed this video. It's quite some time, almost 50 minutes. Alright, thanks for watching, and don't forget to subscribe, of course. Alright.